All right, so I'm sure some of you got up this morning, saw that it was snowing, decided you need to get out of the house early, jump in your car, you're heading over here, you barely see, you're already a little bit frightened of the snow, or at least I am when it's snowing too much. Your phone rings, you think, I'm not going to pick that up because I know that's stupid of me. You know that picking up and talking on your phone while you're driving is like driving drunk, and it's like driving when you're really tired. But you do it anyway because you're an idiot, and you possibly put yourself in a really bad position. So one of the things that the audio dilation group is hoping to help address is keeping you safer when you do idiotic things like talk on your phone while you're driving, or listen to your GPS device while it's giving you instructions while you're driving. Specifically, this is what we're going to be focusing on for our experiment. But some of the other things that audio dilation might be able to help with, especially since we're specifically focused on how it would be reducing cognitive load, would be things like in educational settings where you're dealing with, where non-native speakers are dealing with English instructors or non-native instructors are speaking, and also in social settings. So Thomas here, he listens to music and writes columns for a living, and sometimes he can't understand the fast rap. So maybe he could get that slowed down for him while he's at the concert. To introduce ourselves, start with John.
I'm John. I'm a computer science PhD candidate, and I will be doing a significant portion of the prototype development of the program.
I'm Samir. I'm a bioengineering master's candidate, and I will be doing prototype development in MATLAB, as well as audio engineering and some data analysis.
I'm Thomas, first year master's in communication. I'll be assisting the experimental design and trying to shape some of the messages that we'll be using. We'll be using different passages for the comprehension portion. We've got some questionnaire design involved in it as well.
And I'm Jason Archer. I'm a first-year PhD student in communication as well, and I'll kind of be heading up the experimental design and development portion of the project. So I'll let John take over.
All right. So as Jason said, what we were trying to do is create a prototype application and then test that application, which will dilate audio signals so that people can understand. The hypothesis is that as you slow the speech down, you will have greater intelligibility and less cognitive load. So we put our heads together and came up with what we thought is a minimum, truly minimum set of requirements for what a prototype application would look like. And this prototype is strictly audio. We're not worried about synchronizing audio with video. We're not worried about Skype yet. We're truly focusing on a minimal approach. What we decided was we need the speaker to have some control over when speech, his or her speech, is being dilated. Because right now we have 4 people standing up here, only one person is talking. If we were having a conversation, that would be happening also. The speaker needs to give some control, some indication to the application when he is not speaking, so that the pauses don't also get dilated. On the listener side, what we would like is for the listener to be able to, at the outset of the conversation, to decide approximately how much dilation he needs, because the listener probably has a better idea than anyone else what his or her environment is and what his or her needs are. And because this is going to be, in principle, a two-sided application, we think that it's necessary to have some indication of how much audio still needs to be processed. So what we're looking at is a buffer display on both sides so that the 2 users can kind of manage their own synchronization. So what we would have is something that looks a little bit like this. On the speaker side, there's a button where he would say, all right, I'm speaking, I need to dilate the speech with an indicator light, or I'm not speaking, I would like to stop dilating the speech with a different indicator light. On the listener side, there would be an initial choice of, do I dilate, and if so, approximately how much. And both sides need this indication of how much speech is left to be processed so that they don't keep stepping on each other as they desynchronize in the conversation. Now, the real underlying requirement in a technical sense is that we need to do this online. And I'm going to draw a distinction between online and real time. In reading the technical literature on how these applications tend to work, for instance, for DJ software, Real time tends to mean really fast, which means, all right, I've got a song that lasts 5 minutes. I would like to slow it down. I would like to click a button and have that happen all at once. And it may happen, 10, 15 times faster than the actual sound would take to play. For a conversation that's not going to be good enough, you can't wait until someone has filled up a buffer, 60 seconds worth of speech, or, God forbid, 10 minutes worth of speech before the listener starts hearing things. So we really need to do this online. It has to start processing the pieces of speech immediately. And again, most applications are really fast, much faster than it takes to actually listen to the sound, but they're not truly online. So my principal task is to reverse engineer and reconstruct some pre-existing applications and libraries so that we can do this in the proper online sense. And the way we're going to do that is to change an application that takes large chunks of sound and buffer that application. We store the incoming audio in an input buffer, process the chunks as small as is reasonably practical, send them to an output buffer, and play them back. Now, there is some magic there, because when you get down into the guts of how human speech or music or any sort of interesting sound works, there is some dependency that the later pieces have on the earlier pieces. So that's really the true magic, is making sure that those dependencies are preserved, even though these applications may be residing on different machines and taking place at slightly different times. So with that in mind as the minimum features, some other nice to have features would be letting the listener modify the dilation rate. For instance, if his environment changes or if he realizes that he estimated his needs incorrectly. And that gets into some interesting technical issues of what do you do with the buffer that's already been processed, how do you make sure that you maintain synchronization. It would be nice to let the listener pause or hit a button and go backwards a couple of seconds, TiVo style. And Professor Kenyon made the suggestion that if we're going to do that, and maybe even if we don't, it would also be interesting to see if we can compress the speech to let the listener decide, all right, I want to catch up quickly. I don't think the speaker is saying anything important, just fast forward. Some of the applications that we have in mind, it would be nice to be able to chain the dilation rate to an external signal or stimulus. For instance, when you're driving your car, sometimes you're on a side street going to the highway, sometimes you're on the highway. It would be nice if we could hook this up to the accelerometer or the GPS in a phone and say, all right, I can sense that the user is going 60 miles an hour, or in my case, perhaps 80 miles an hour. We should really slow that speech down more than when you're driving on a side street. We would really like to be able to automatically detect the speaker silences so that we can remove a lot of the burden from the speaker, because I'm quite certain that people are going to forget to hit the button or just aren't going to want to hit the button. That's a technical challenge also. And everything that I've said so far is a true prototype, in the sense it's probably going to be residing both ends of it on my laptop. We'd like to actually make this into a networked application so we can try it on 2 laptops over the internet, but that's its own special challenge. So the way I've partitioned the tasks out for this is, first, proof of concept, implement a non-buffered application just to make sure that we understand the math, make sure that we understand what the processing requirements are. We've done that on my middle-aged laptop. 30 seconds of speech processes in about 4 seconds. So that's an encouraging result. We think that we ought to be able to do this in near real time. Next, we have to decide what language we're actually going to do this in. So far, all of our prototypes have been in MATLAB, which is very, very convenient for prototyping algorithms, but it's not good for real standalone applications. So we're looking at Java versus C++, really based on personal familiarity of programmers. I'm in the process of building the prototype in Java just to make sure that it goes fast enough. After that, we need to do the initial prototype with all those minimal requirements that we mentioned up front, get the user interface working, get the buffer approach properly implemented, write it on one machine, and then hand it over to the rest of the team to see if there's any glaring flaws, or start reprioritizing some of those additional tasks. Haven't started on that yet. And then, if all goes well, if we really, if this turns out to be something that we can do and finish ahead of time, consult with the team and see what additional features are practical to implement, like the slider for the dilation rate, so that the listener can modify his dilation in real time, or the listener pause or the TiVo. And then for the really advanced prototype, we'd like to get this networked, and we'd really like to be able to auto-detect when the speaker is not speaking.
All right, so I'll take over from here.
Can I ask a very quick question?
Of course.
You mentioned you have a little test working in MATLAB, right?
Yes.
Is it possible to rig up your MATLAB prototype so that you simply sit someone in front of the simulator now and just use your MATLAB prototype and just get a gauge of just having someone driving the simulator and just try and talk to them? And
when you say now, do you mean
with what you got? No, I mean not online now. I mean, try this as just get the pieces together real quick.
Not quite.
Okay.
The missing part. And MATLAB has object-orienting capabilities, but I have not really implemented a buffer. What I've done is I've taken a sound file.
Oh, I see.
And said, all right, this is, if we were to do a buffered approach, this is how the math would work. Let's fake it. So it's buffering like, not actually buffering.
I thought maybe if you could rig up MATLAB to, in a loop, grab 5-second buffers, and then just do the dilation, and then start spitting that out right away, and then just have someone in another room talking, and the mic, and then have someone sitting in the simulator listening, just to see what happens.
We want to do that. I think I want to do that in Java, though, because I think we're going to end up doing the real application in Java. So what you're suggesting is something that we want to do very soon.
Okay, so that's the technical side of the project at this point. The other part of it is obviously experiment. How are we going to find out whether dilating audio even matters, and what types of dilation work to reduce cognitive load if they in fact do. So one of the things that we're considering with the experiment is that it's going to have a modular design so that you can add and take away variables as necessary depending on the apparatus that you're using. We've decided to stick with the dual task using the driving simulator and listening, which was first proposed to us. One, because it's topically relevant. Like I said at the beginning, there is an actual legitimate case to be made that it could make people safer while they're driving. So it has a real life application immediately if we find out that it works. And we're going to use randomized conditions because we have a lot of variables, and we'll talk about that as we go on. So here are two of the overarching research questions that we're considering. The first is, does temporally stretched speech improve driving performance and/or speech comprehension? And the second, which kind of will actually end up being the first, is, does temporally stretched speech improve speech comprehension in noisy environments? And that should actually, I had changed this slide and then I got the incorrect version, but it should actually just say, does dilated speech improve speech comprehension in noisy environments? Because we want to test not just slower speech, but also sped up speech in this case, just to be counterintuitive. So one of the first things we're going to do, kind of as a pilot study, is find out whether or not we can find a sweet spot for speech audio dilation. So is there a certain speed at which you no longer gain more comprehension or you lose comprehension? And the reason for doing this is, one, to test in the noisy environments to talk about our second research question, but it's also in order to cut down on the variables we would necessarily need to test in the driving simulator so that we can focus on other variables. The main part of the experiment, the independent variables for the main part of the experiment will be different dilation rates. 1.0 means the normal dilation speed, 1.2 is going to be slower, 1.4 is going to be even slower. So again, we might be able to cut back on these variables. We'd like to test several different kinds of speakers. So you'd have a native English speaker, or whatever speaker is going to be the same as the population that you're speaking to, and then accented speakers. And so I have two down here, because we might find that accented, depending on the accent, that might have more to do with comprehension and workload than speed does, for instance, alone. And then the driving simulator, it comes ready to go with two different driving modules, and that's a city module and a rural module. So right now, as this is laid out, that looks like 3 times 3, 9, 18 18 conditions that we have in here. So maybe a few too many. Dependent variables that we'll be looking at. The driving simulator is also nice in that it has some things that are somewhat maybe easy to measure. This would be things like lane position, speed, brake reaction, and then the comprehension test, which we will have to develop. And the way that we're thinking about developing that comprehension test is based on either using passages that have already been used for similar tests in testing speech, and we've gotten some ideas. There's a group in Northwestern who's created some accented passages, 3 or 4 different passages, and created tests. We could either use something like that, or we may be developing our own comprehension test, depending on what works best. So in the very beginning, what we're going to do starting next week, and we'll see this on the timeline later, is that we're going to go get in the driving simulator, drive it, get a sense of the data. One thing that was brought up to us, one of the limitations of the driving simulator, is that it takes a while to get used to. And so we need to see about how long it takes to get used to the driving simulator, because that's going to have an effect on how long the rest of our tests can run, obviously. How easily do you get fatigued? How long can you run without the track looping on itself? These are also things we need to figure out before we can figure out how many variables to test. It's kind of an idea of the procedure. How it would look at this point is that each condition would be a sequence of about 5 minutes. The participant would be driving for 3 or 4 minutes, and within that 3 or 4 minute driving period, there would be the audio passages that would last about 2 minutes. The driver would then stop, be given a comprehension test, a multiple choice, not multiple choice, but a questionnaire that might be something like, depending on the passage, what was the color of the house, or what was the name of the dog? And before they would fill out those answers, they would do this count back thing that helps. It's like a buffer so that they're not memorizing what they are hearing while they're driving, right? So if you make them do something, if you make people do something like this, it like kind of provides a break, I guess. And then we repeat with other conditions. So as this is set up, you see that if there's 12 conditions, you're already looking at an hour of driving time. This is the other thing. We probably won't get to a full experiment within the time that we have in this class, but what we do need to do is pilot this experiment to deal with things like, is our comprehension test working? Is the driving simulator going to be working? Is this getting at what we're trying to get at? So towards the end of the semester in April, we're going to be asking classmates to sign up to do pilot study, or to be our pilot participants. So, and Samir will talk about that a little bit at the end. And then once that's all done, the idea is that we would make refinements. We would scale it up in order to be able to run the test over the summer if we were finding some significant results, and seek IRB approval, run the experiment, save lives. So Thomas is going to talk about the timeline for a minute.
Yeah, we can run through our timeline real quick. This is just the experimental side of things. We'll be getting the driving simulator over into this lab hopefully next week, and sit down and start working through it, start developing some of the tests. We've got a little bit of a lit review to do, just looking up to see hopefully some similar tests and some questions that we might be able to borrow from other studies, as well as maybe having to craft some of our own. The week after that, yes, scheduling participants. You can assist in the development of science. We, like you said, probably coming up in April, we'll be running some of these, and hopefully we'll be signing some of you up. We'll be coming to you and talking on Course Kit about scheduling some of these if you want to go for a pole position drive. The sweet spot test coming up after that, right ahead of our progress report at the end of that week, and some of the ambient sound development that we might be coming up with. Then we have, is this? No.
This is mine. This is, we're hoping to do this far by late March, which is, again, this is really just the task list from the very basic prototype, the interface and the buffer dilation, and letting the users take control of the application, even though they're going to be on the same machine.
And then we're going to go all into our spring break, and we're going to drink for a week, and then we'll come back.
Yeah, I don't want spring break. Very sad.
And as mentioned, in the month of April, we'll be running the tests. We'll we'll probably have to go through a batch of them and then evaluate some of the results that we get and maybe make some tweaks and then come back and do some more.
April 30th, write up our results, so on and so forth, and the final week we'll present. And that is it, I think. Any questions? Oh, and then this is the other thing that our whole team is going to be doing, saving lives. Yeah.
My first question is totally dumb, but I'm not sure I know what audio dilating is. Could you elaborate on that?
That means slowing down the rate of the sounds without introducing other distortion. So the easy way to do this, and the wrong way, would simply be to change the sampling rate so that the sound gets slower and slower. But if you do it in that naive way, the sound also gets lower and lower.
Like when
like when you're playing a record at the wrong side.
Oh, okay.
So there are techniques with various types of spectral analysis and magic to get the one thing that we do want, which is the dilation, without getting many of the other effects.
Okay. And then my other questions are about the design. So you have 3 factors, 3 by 3 by 2, so 3 different speeds, and 3 languages and 2 conditions.
Right. I mean, that's one of the things we'll be working out. If we do that sweet spot test, and we are able to take out one of those speed conditions, for instance, then it'd be 2 by 3, or we might take out an accent condition.
Because the 3,
really, we're looking for 12 would be probably the maximum amount of variables that we'd actually be looking to do in the experiment. But for the reason of just showing the types of modulations that we could do to the experiment, I put them all.
Sure, because that is. That's a lot of conditions, and just the analysis is very hairy. And also, if you only have like 10, 15 participants, I don't know how are you going to get. Is that between or within? Is the design between? So is one person? It's within. So you'd be repeating everything?
And that's what the randomized conditions are about. So that each participant would be going through the 12 conditions, but each one would be going through them in a different way. So that you hope to, go ahead.
My question, I mean, for the speed, it's okay, but for the one in which you get the language in different versions, there's going to be a learning component.
We'd have different passages. It wouldn't be the same passage repeated. You'd have, that's a good question. So each passage, each passage in each speed and each accented version would have to have different. So you'd have to have 11 different passages.
And then, how are you going to be able to compare? Between passages, because if they're not the same, I mean, if you're varying more than just, I think it was English and then version 1, version 2, is that different passages or different dialects of English or different ways of saying it? So it's just...
It would be different dialects, or I mean, the idea is that it'd be non-native speaker in with their accent would be, but it would be different passages as well.
So you're varying 2 things. You're varying the content and the way in which you deliver that content. So you're going to be very careful because there's a confusion here.
Right. It's kind of unclear.
So I don't know, but it might be better to just, scale down on the variation to be able to have more controllability.
Okay. Yeah, that's a good point.
Yeah, one thought I had was that we could use formulaic passages so that there's just like certain words that change, but that definitely needs to be processed.
Yeah, you have to be careful because the first critique you're going to get is this is just comparing apples and oranges. So.
Okay, that's good. That's a good point.
It's a really, great experiment.
Valerie, do you have any questions?
I have a couple of points, but I think nothing. I mean, I think the points that were just raised were good points. And there is certainly something we can consider how to modify. But overall, I think the project, for both projects, is shaping up, and I can speak with the students directly about. I have just some specific, more technical points. I think overall, things look good.
Okay, great.